Most drivers think battery failure happens suddenly. The engine doesn't crank one morning, and they assume the battery simply died. But battery failure almost always develops slowly, caused by habits most people repeat every day without realizing it. Today, you'll learn the exact actions that make a battery last twice as long, even in modern vehicles with smart alternators, start-stop systems, and sensitive electronics. Number 1. Stop low-voltage cycling. Modern vehicles often undercharge the battery by design. Short trips, brake energy regeneration, and smart alternators that reduce load for fuel efficiency all contribute to the battery spending too much time below a healthy voltage. A healthy resting battery should read 12.6 to 12.8 volts, fully charged. Around 12.4 volts, sulfation begins. Below 12.2 volts, sulfation accelerates. Checking voltage regularly prevents the battery from sitting at damaging levels. If resting voltage falls below 12.5 volts, restore charge with a low-amp external charger. Alternators are designed to maintain charge, not recover deep discharge, especially modern controlled units. Keeping voltage high slows sulfation and preserves capacity. Number 2. Maintain clean, low-resistance connections. Corrosion and loose clamps increase electrical resistance. Even small increases force the charging system to work harder and reduce charging accuracy. Proper maintenance includes cleaning battery posts and clamps with a wire brush, applying dielectric grease only on the outside of terminals, not between contact points, tightening clamps to proper torque, inspecting ground straps for corrosion or cracks. Different vehicles use different grounding designs. The important part is that the intended contact surfaces stay clean and conductive. Stable, low-resistance connections ensure correct sensor readings and consistent charging. Number 3. Manage battery temperature correctly. Heat is the number one killer of batteries. Cold doesn't cause permanent damage, but it exposes any weakness by reducing available power. Important temperature points: above 30 degrees Celsius or 86 degrees Fahrenheit, chemical degradation speeds up. Below 0 degrees Fahrenheit, cranking power drops sharply. Modern vehicles manage temperature differently depending on battery location and factory design. Best practices include keeping factory insulation and heat shields intact, avoiding modifications that expose the battery to engine bay hotspots, using battery blankets only in extreme cold or extreme heat, parking in shade when possible. Maintaining temperature stability dramatically increases battery lifespan. Number 4. Understand parasitic drain. After control modules go into sleep mode, many vehicles stabilize between 20 and 50 milliamps of parasitic draw. Some European vehicles naturally settle between 70 and 90 milliamps, which is normal for them. The goal is not hitting a single number, it is identifying abnormal drain. Aftermarket accessories such as dash cams, LED controllers, and tracking units often increase draw. If the drain is too high, the battery experiences nightly microcycles that shorten lifespan. Accessories should use switched power or proper power management modules to avoid unnecessary drain when the vehicle is parked. Number 5. Don't use the alternator to recover a weak battery. Older alternators charge continuously at predictable voltages. Modern alternators adjust output based on temperature, load, and efficiency strategies. This means, after a jump start, the battery may not fully recharge during driving. Recovering a low battery through the alternator overheats the alternator windings. Rapid high current charging can warp battery plates. Smart alternators often reduce charge earlier than traditional units. If voltage falls below 12.2 volts, use an external charger. It is safer, cooler, and far more effective. This protects both the battery and the alternator. Number 6. Flooded battery electrolyte checks. Most modern vehicles, especially those with start-stop systems, use AGM or EFB batteries, which do not require electrolyte maintenance. But many trucks, older vehicles, and basic models still use serviceable flooded batteries. When applicable, ensure electrolyte covers the plates. Add distilled water only. Check levels every 5,000 to 7,000 kilometers. This step prevents plate exposure and internal corrosion in batteries that require regular maintenance. Number 7. Avoid storing the battery at partial charge. Sulfation increases the longer a battery sits at a low voltage. Use this voltage guide. 12.6 volts or higher, fully charged. 12.4 volts, moderate charge. 12.0 volts, severe undercharge. If the vehicle sits for more than 1 week, a battery maintainer is extremely effective. Choose models with temperature compensation. Avoid cheap desulfation chargers that use aggressive high-voltage pulses. These can damage AGM batteries. Keeping voltage stable during storage is one of the best ways to extend battery life. Number 8. Maintain the ground network correctly. Weak or corroded grounds cause voltage instability and reduce battery lifespan. But not all ground points should be sanded or polished. Some surfaces are plated or engineered for long-term contact. Best practices: ensure ground straps are clean, tight, and unbroken. Clean only the intended metal-to-metal contact areas. Avoid sanding coated surfaces that are not meant to be conductive. Keep engine and chassis grounds corrosion-free. Good grounding ensures stable voltage throughout the vehicle. Number 9. Avoid excessive electrical load at idle. Alternator output at idle varies by vehicle. Some alternators provide 30 to 50% of their rated capacity. Others provide much less due to smart charging systems. If electrical demand exceeds output, the battery supplies the extra current, causing unnecessary cycling. To avoid this, limit heavy electrical loads during short trips. Avoid adding unnecessary aftermarket accessories. Allow RPM to rise naturally before using high-draw equipment. This reduces strain and preserves battery capacity. Number 10. Perform accurate load testing. Load testing reveals internal resistance and cranking ability, but results depend on temperature. Standard guideline: minimum 9.6 volts under load. At 21 degrees Celsius or 70 degrees Fahrenheit. Colder temperatures require adjusted thresholds. Modern testers often combine load testing with conductance testing, which is especially useful for AGM and EFB batteries. Testing once per year, ideally before winter, helps identify early signs of failure. Number 11. Choose the correct replacement battery. Battery replacement must align with the vehicle's charging strategy. Modern vehicles may require EFB batteries for start-stop systems, AGM batteries for high electrical loads, battery registration or coding, common in BMW, Audi, Mercedes VW, and Mini. Proper matching of reserve capacity. Not only cold cranking amps installing the wrong type can shorten lifespan if the charging profile doesn't match. Choosing the correct chemistry and capacity is one of the most important factors in long-term durability. Number 12. Maintain the entire charging system. A long-lasting battery requires a stable charging environment. Modern systems include smart alternators, LIN bus voltage regulators, temperature-controlled charging logic, DC to DC converters in hybrid vehicles. If any part of this system undercharges or overcharges, the battery ages prematurely. Key maintenance includes monitoring charging voltage, typically 13.8 to 14.6 volts, depending on conditions, inspecting belts and pulleys, checking for voltage drop across cables, observing regulator behavior through scan tool data. A stable, well-regulated charging system protects battery health.